Hello and welcome to my channel. In this video I want to show you the procedure for putting sprites on the border. This is a hack and it works against the VIC-II chip to trick it into going into a mode it shouldn't be going into. The effect is quite nice because when you're out of screen real estate you can then put messages like I have here into the border. I think I was inspired to do this by the video game Turrican. What I noticed in the game's loader screen is that the entire screen was used as a bitmap, and then messages were put in the border to tell you what to do. I thought that was really cool, and I had some use cases for that. So I'd like to show you the sprites in memory just to show how they're being used. I have a large set of sprites here, and it's the entire English alphabet of letters. So I could pretty much spell any word that I want using the sprites. Next up, let's have a look at the machine language using the Super Snapshots monitor. The machine language by default is located at C000. And what you're seeing here is the standard procedure for setting up an interrupt. We first disable the interrupts, then we define a location for the interrupt handler at C022, and then we set a couple parameters here, a couple registers, and then at F8 raster line, we define where we want the interrupt to start. By setting this value, we tell it how we want to start the interrupt, or when we want the interrupt to start. And then after that, we just set the correct video mode and return to the calling system. Now we have the interrupt itself, and first thing we want to do is increment the D019. This is the latch which tells the system that an interrupt has occurred. If you don't do it, this won't work. And since we're now at the F8 raster line because this interrupt was called, we can now set our preferred video mode, which is actually 24 line mode. Then we wait for raster line 4 to cycle around. And when that happens, we can reset the video mode back to 25 line mode and then escape. This EA31 address is the kernel location. It allows the system to continue doing maintenance and other routines. Now that I've shown you the components of this trick, I'll show you how to create the trick for yourself. Starting from reboot, I've placed some notes on the screen to show some of the parameters that we need to understand to get this to work. First of all, by default, you have 38,911 basic bytes free. And this is made from basic RAM, which starts usually from 800 hexadecimal to 9FFF hexadecimal. And that's followed with basic ROM that's from A000 to BFFF. But the VIC-II video processor has the default bank of 0, and that sees the first 16K of memory from 0 all the way up to 3FFF hexadecimal. So we have a problem of overlapping memory. To make it go a little better, we'll limit basic to the first 10K of memory from 800 hexadecimal to 2FFF. And then we can load sprites into location 3000 hexadecimal. So let's do it. I found this trick online. It's very easy. Basic is now using just 10K of RAM. With that out of the way, let's start loading the components. First thing, sprites. Load them in at 3000 hexadecimal. I think building sprites is out of scope for this. These are my sprites. If you want to use sprites, you'll have to build your own. And now let's use a basic program to load the machine language into memory. This machine language is relocatable. I picked a starting address of 49152 or C000 hexadecimal. Since there are some location-dependent interrupt routines, we have to do some math here to find the high and low addresses of that and stick that back into the code. Only 57 bytes of code. It is now in memory and it's ready to go. So moving on, let's now go to the sprite demo. I made this program to facilitate viewing the sprites in BASIC. After activating the interrupt, we can then run the program to set up the sprites. And here we are. We have 25 lines of text and we have sprites on the border. These borders are defined for NTSC mode. If you're in PAL, then you would have to make some adjustments as to where the rasters begin and end. We have those black graphics on the border, which we don't want. This is the ghost byte, and it's just an artifact of the VIC chip. The last location in the bank of memory of 16K, at 3FFF in this case, that's where it is drawing the graphic from. So if we want to fix that, let's set it to 0. And there it is. It's invisible, it's nice and clean the way we want it. For pragmatism, I've glossed over some details. There are other YouTubers who will go more into detail on some of these subjects. But I wanted to give you something that you can use and you don't necessarily have to understand it completely. So that's it. Thanks for watching.